Hi, this is Group 11's final presentation of our project, a multimodal recommender system for ontologically mismatched entertainment domains. So this is the outline of what it is that we're going to talk about today. We'll start off with a high-level introduction and system overview, followed by a description of the data sets and some of the exploratory data analysis, followed by the meat and potatoes of the solution with the AI agent and the recommender system, followed by the results and the live demo. So the project set out to create a recommender system capable of generating meaningful recommendations across multiple entertainment domains. We used an AI agent to engage with users to elicit preferences that are then passed to the recommendation system to solve the cold start problem. The cold start problem is when a recommendation system doesn't have a profile built for a specific user or item, so you can't align what somebody's preferences are to what's already in the database. The project leverages data sets across 3 entertainment domains: books, movies, video games, with each of them consisting of multiple data sets of various size. So the high-level system overview, you can see that the user interfaces with a front-end app, which then communicates with the AI conversational agent. The AI agent asks questions and interacts with the user to develop a list of responses and preferences, which then gets fed into the recommender system, and that engages the data pipeline to extract a recommendation in a particular entertainment domain that the user would be interested in based on their real-time feedback. So you can see that we use 3 different high-level entertainment domains for our project: video games, books, and movies. Each of those entertainment domains consisted of different file types, different file sizes, with a lot of different features. We essentially had 2 options. The first, to converge to a single usable database with a consistent schema used across all of the entertainment domains, or leverage each individual database for each domain. And our preference was option 1, to converge to a single usable database. So before we could get into the backbone of the system with the AI agent and the recommender system, we had to do some exploratory data analysis, which involved reviewing each of the files in each of the entertainment domains. And that included feature engineering and data wrangling, which enabled us to create the single usable database with a consistent schema. We had to create some new features. We removed titles with less than 30 reviews, so that way all of the recommendations were highly reviewed and there was a higher probability that it would actually match what the user was looking for. We merged features for data consistency. We joined multiple data sets. We also calculated and normalized ratings data, which was probably the most interesting thing that we did, because the video games data set didn't actually have user rating on the scale of 1 to 5, which was typical of the others. It had total counts of positive and negative reviews. So what we did there was we essentially calculated to a positive percentage, and then we scaled that to within the range of 1 to 5. So we had a consistent 1 through 5 rating that was the same as the books and the video game, the books and the movie rating scale.
Now that we better understand our data, we can move on to building the AI agent, the brains behind this application. The application we are building is a web-based AI agent that extracts users' preferences by asking a series of questions. These preferences are then fed into a recommendation engine that produces content recommendations for a user. The architecture of this application is entirely based in Python, leveraging common open source packages and frameworks. LangChain is the framework we use for the backend, which provides us with easy API connectors, simplifying our connections to other applications. For our front end, we leverage the Chatlit open source package, which provides an easy-to-use framework for the front end. This allowed us to create our front end simply in Python, rather than having to use another language like Java. To power this agent, we leveraged Microsoft's Azure OpenAI models. From this service, we were able to access 3 common OpenAI models that we tested: GPT-4o, GPT-4o Mini, and finally O4 Mini, the new reasoning model. To further break down how this application works behind the scenes, we can really look at this as 3 key components. The first component, the snapshot generator, provides the LLM with context of the database so it can better understand what kind of questions the model can ask. This is the big differentiator between this agent and standard ChatGPT, as this model has prior knowledge of the database so it can better ask informed questions. The next component is the LLM question generator. This uses the snapshot to provide context-based questions to collect the user preferences. These preferences are then fed into the final component, the recommendation engine. The recommendation engine takes the user preferences and generates content recommendations. Yash will now tell you more about this engine later in this presentation. Now that we understand the backend, we'll move on to the user experience. The user will first be greeted by three buttons, allowing them to choose a content type. Once they select the content type, the model will ask the user a series of questions to gather their preferences. Once the user answers all of the questions, the recommendation engine quickly generates and provides three recommendations to the user.
On this slide, we will drill down into the core of our recommender pipeline. First, the AI agent collects up to 15 structured preference input from the user, everything from your favorite genre to the minimum rating threshold. Next, we will filter those preferences by domain, book, movies, or games, and apply any genre rating or platform constraint. Finally, we will normalize average rating across our master data frame and rank diagrams, returning the top 5 matches. This design not only solves the cold start problem via conversational LLM prompts, but also ensure a consistent schema across all three entertainment domains. Here you can see the three key backend components powering our engine. The snapshot generator map each of our data sources, title, genre tags into a unified context for LLM. The question generator for then uses ChatGPT 4.0 to adaptively craft follow-up questions based on earlier responses, making preferences elicitable but efficient and engaging. Finally, the recommender engine executes a domain-aware, filter-based selection algorithm on our unified master data frame. On the front end, Chainlit provides the interactive UI with buttons to select domains and a conversational chat preference that parses JSON responses into the real time. To evaluate the reliability of our AI agent, we define the hallucination rate as the ratio of the successful, well-formatted JSON output (LS) to the total prompt send IT. A lower hallucination rate indicates fewer malfunction or missing preferences structure, which is critical for downstream recommendation accuracy. In our experiment, ChatGPT 4.0 consistently outperformed alternative models, achieving the lowest hallucination rate, demonstrating its superior ability to return valid structured JSON even under dynamic conversational prompts. Our system delivers consistent domain-agnostic recommendations, and user feedback confirms that the concise, high-quality top 5 lists were preferred. The filtering mechanism by genre, rating, and platform provided effective in honing on relevant items. However, we have observed two main limitations. The LLM can be sensitive to subtle prompt changes, require a fallback logic, and semantic rigidity causes closely related genres to be treated as distinct. Looking ahead, we can plan to integrate semantic similarities, embedding, and fuzzy matching to improve better capture of nuances of user intent, further improving the recommender's relevance and robustness.
Now we will give you a quick demo of how to use our content recommendation application. First, when you load the application, you will see a screen like this asking you for what kind of recommendations you would like. I will select my video games because I want a video game recommendation. Then it will ask you a series of questions gathering your preferences. The more detail you can provide the model when providing your preferences will allow the model to give you better recommendations as it has more to go off of. The model will ask a series of questions. In this case, we are going with 5 questions, but you can always update the settings in the backend to allow you to answer more questions to gather more preferences. So we can see as we are answering more questions, it continues to refine its questions to get closer to giving you a meaningful recommendation. Once it finishes, it will say stop and let me pull some options for you. Where here we can see some video game recommendations. Now we can see the rating of the recommendations as well. telling us that these are highly recommended games and things that it really thinks we would enjoy. What's nice is we has also included the tags here to give you a little bit more detail about the game, to help you really understand what you're looking at with these recommendations and why the model may have picked these preferences for you. I really hope you enjoyed this demo and really hope you get to use our application and get some great content recommendations. Have a nice day.